Everyone, welcome back. Today we're going to continue to be thinking about this concept of division, but we're going to be talking about with this concept of remainders, right? We've known this whole time as we work that division is really all about equal groups, but what happens when those groups aren't equal? Like what happens if it does not work, right? Like what happens when 15 people show up to play a game of football and you're going to split into two teams, right? How is this going to work in the case of what happens? Well, let's even look at this in a divisional standpoint right now. Like let's put this together maybe of equal groupings here. We're going to have two teams, right? We're going to have two teams. We could just put out our two circles, and then we got our 15 people that we distribute into each one, right? So like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, 15. And if we counted and looked at like who's in each one, right? We have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. These aren't equal groups. Like there's nothing equal about that here. So we have to start thinking about like, well, what does that mean? Right? In this situation, probably this is the case. We might make a team of 8 and a team of 7. We're not going to tell that one person, go home, you can't be on a team. That wouldn't make them happy, right? But like, what does this look like in division? Like, how do we put this together? So let's explore that a little bit more, and let's just jump into a couple problems here. Let's go ahead and take 19 and divide it by 3, right? So I'm going to use the equal grouping method. So I'm going to just kind of use our circles to do this. And let's break that apart and think we have 3 groups. And then again, I want the same amount in each group. So I'm going to start putting that out there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, right? I'm not at 19 yet, but notice I have the same amount in each. There's 3 in each. So let's see, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now, this is where I'm going to pause because as you can see, I'm at 18 of the 19 we have. But in this case, they all have the same amount, right? They all have the same amount. This has 6 in it. This has 6 in it. This has 6 in it. So that works. That's the equal grouping that we want. But then we have to ask ourselves, well, what about the one that's left over, right? So this is how we present this. We do want to take it to this point. We want to talk about how many would make an equal group. And in this case, 6 make equal groups, but then we have this 1 left over, right? And this is the remainder. It's what's left over. It's this 1 that can't go into any other groups, because if I put it in here, that would make 7, and we don't want that. If I put it over here, that makes 7. We don't want that. If I put it over here, that makes 7, and we wouldn't want that because it wouldn't be even anymore. 1 would have 7, and the other 2 of them would have 6. So how do we represent this remainder is a good question, right? We want to talk about what's left over. Well, what's left over is the 1. The 1 is what's left over. So we have 6 with a remainder. We're going to say a little r here, and this is the beginning. We're going to change this soon, but this is the beginning of how we can write this. Remainder of 1. So we have 6 with a remainder of 1. So again, let's just keep practicing. In this case, let's take 25 and divide it by 4. Go ahead and pause and try this if you would like. So you're coming back from the pause and see what you got. Let's put it together. So if we're going to use the circle method, I have 4 of them. So these equal groups, these 4 equal groups. And then let's put some things in. I'm going to go ahead and move to the skip counting part. So I'm going to say like we have 5, 10, 15, 20. Okay. 21, 22, 23, 24. 24. So I'm at 24. So that's not going to work because I can't put 1 more in each of them, right? So what we have in each is 6. Oh, this is interesting. This will not always be the case. I love it when this happens. We get like the same answers. So there's 6 in each group, right? but we only got to 24. So what's left over is 1. And we can even look at that if we subtracted this, what's left over is the 1. So we have 6 with a remainder of 1, right? Because we can put 6 into each group to make it equal. But that didn't get us to 25. It got us to 24. So we have 1 left over. Let's try another example of where hopefully the answer is not 6, remainder 1. Let's go ahead and take 18. And let's divide 18 by 5. All right, so we need our 5 equal groups. And then let's distribute 18 out there. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Let's see. 16, 17, 18. Yeah, it wouldn't work, right? So that got me to 18. So let's see, there's 1, 2, 3 that I can't put in there. So I only got to 15. That's as high as I got. And now we can't have these in here. Let's get rid of them. Those will be our remainders, which looks like there's 3 of them. But let's look at what we have in each, what worked. What worked in each one was 3. I had 3 here, I had 3 here, 3 here. All right, so 3 worked in each, but when I did that, it only got me to 15, but that's okay. So we have an answer of 3. And then what's our remainder, right? Our remainder is the difference, what was left over. And we had a remainder of 3. We had 3 we couldn't put in. All right. So that's kind of where we're going. And I think, honestly, if you're like, I don't know if this really clicks with me, that's okay. We're going to keep practicing it with the circle method. When we get into more of an algorithm approach, I think seeing the remainder will make a lot more sense. I really do believe that. But let's just keep playing with this. Let's take 21 and let's divide it by, I don't know, what do you want to divide it by? Let's divide it by 6. Okay. So we're going to need 6 equal groups. 2, 3, 4, 5, 6. And then we're going to distribute this 21 into it, right? I'm going to work with 2s for now. Let's see, 2, 4, 6, 8, 10, 12. Okay, 13, 14, 15, 16, 17, 18. Now, if I kept going, right, that would be 19, 20, 21. So, man, I tell you, this is not the case. We're going to set the same answers every time. Answers will be different. This is just coincidental. This keeps happening. So as you can see, like, these are my leftovers because they actually can't go into the group. I can't have them in there. Okay, so then let's go and look at what we have. Right? Each one equally has 3, which means I have my first answer of 3, and then the remainder was what were the ones we couldn't use. Well, we couldn't use this one, we couldn't use this one, and we couldn't use this one, so this also has a remainder of 3. Coincidental, that was the same answer as the answer from the one before. I don't know what's going on with that. So I got to do one more. Let's just try one more out. Hopefully we will not get one other answer or the same answer again. Let's do 15 divided by, what do you think, 7? Let's do that. Let's divide by 7. Okay, that's cool. Let's get into that. Let's see how that works. So we're going to have 7 groups. 1, 2, 3, 4, 5, 6, 7. And we're going to put our 15 into it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there's that one that wouldn't work. We don't want that one. That doesn't work because now we have 2 in each group. And then here was that leftover one. So a remainder of 1. Okay. So don't worry, there's going to be more of this. Like, we're going to look at this as an algorithm, but I hope this kind of gives you a start and a feel of what might be coming with this concept of what's left over as a remainder. We'll be talking about it more, but for now, go ahead and keep trying, keep practicing, ask those questions. As always, we appreciate your time. Thank you for being here. Thank you for working hard, and we will see you soon.